Thank you. Okay, so we've got 40 minutes and a few exceptions to work with or fight against. So we saw this analyst exception. Hue is not a valid SQL data source, and I'm pretty sure that you may have guessed already why it's the case. We haven't described this data source in any way, any meaningful way. If you look at this code, look at this. What is this doing, okay? Just providing name, and that's it. So that's not a complete data source. And we are lucky because in this combo, IntelliJ IDEA plus Spark SQL sources that were downloaded by SBT, another lovely tool, we can click this and notice that this is the case, the last case where, well, something before didn't click or didn't happen. So scrolling up to resolve relation, we see that somehow we ended up in this code, resolve relation. And look at this, providing class, it's us. This is the class that we defined. New instance, we created new instance of this class. Again, the class we developed, it's just this, nothing else. And now, ladies and gentlemen, we are checking what interfaces we implement. So without much thinking, yeah, I know how it is. We don't have that much time. As a matter of fact, I don't have either. So I just click this, and let's see what's going to happen when we implement this contract. There are a couple of contracts we can implement. Some are, exclusive, some are not. It's just for different cases. For example, schema relation provider. You will see it in a moment. So then you do something like with schema relation provider, and you know that now you need to implement this weird formatting. Anyway, okay, so now you know that you need to implement these methods, create a relation, done. Okay, that's all we had to do to implement this schema relation provider. Let's see how it changed, how it influenced our code. So here we are Spark SQL extension developer. Here we are just, Spark SQL developer. So we use this high-level API to describe our flow, our input data source. Let's run it. Let's see if we see different exception, or perhaps everything is gonna be fine. No, it's not. And this is because, as you will see, a schema needs to be specified when using Hue. What? Hugh, did you do this on purpose? Okay, so it was a deliberate choice. So he decided that whenever we ask him for anything, we need to specify schema. What kind of schema? Well, schema of the data we are dealing with. Where to describe it? Well, using this nice high-level API called Data Frame API. And let me do this nice formatting, so you'll see it better. And after format, we say schema, and we define schema, okay? So let's define the schema, and the schema is gonna be, that's simple. Okay, done. Let's see what's gonna happen now. So we only changed our code because Hue requires that we end users specify schema of our data. That's it, because that's the purpose of this contract. Schema relation provider. And the exception was because as you click it again, you see schema relation provider with none. None means user-specified schema. And then we see analyzes exception. That's it. We thought we are going to be here. No, it was not the case. Now it will. Because now we specified schema, that's why it's some. Let's see. Test. obviously, we could also have changed the interface we implement and see different exception, just like what we see now, okay? Scala not implemented error. Fantastic exception. I love this while teaching people how to extend Spark, how to write Scala Spark code or Kafka, because, well, that's exactly the purpose of this triple question marks. And you click this and you see create relation. So, ladies and gentlemen, we need to implement this, this base exception. Let me format it manually because I hate what's provided out of the box in IntelliJ IDEA, and because I upgraded this just before the session, I haven't changed it. So, we need to provide base relation. We've got no idea what base relation is all about, right? Is there anyone who understands this concept of base relation? No, no one, which is fine, which is exactly the purpose of this talk. So, what I usually do is do this. New base relation, tab it, we're done. Yeah, that's exactly what I'm doing. I'm too old for fancy articles about, how to do things right. I just do this live coding, and I'm showing you that that's the perfect for, fast prototyping. And Spark allows this and in a nice, very nice way, together with IntelliJ IDEA and SBT and some other, cool stuff like, for example, Scala. So let's run it. We'll see another exception, yes, different one, but this time, as you see, it's this. We haven't provided schema. Well, look at this. We get schema from user. We need to provide schema, so I'm lazy. Look at this. I do this. Hop. Apps. Done. The purpose of the schema is so Spark SQL knows how to work with the data that's available through this venue called Hue data source. So whether it's something that user provided or you inferred from your data source, from the system you are accessing data from, it's up to you. Okay, it's up to the interface, up to the contract you implement, your data source implements. Let's see. Yeah. So, no plan for relation. Awesome. When I saw it the very first time, it was like, what is this? What is this planner? Query planner? Wow, that's something sophisticated. I know that people from Databricks, they are pretty clever, and they figured a nice way to make our life tougher, easier. So pardon my mistakes. But hey, you know what? Let's read a little bit, just a little bit, about base relation. Base relation says nothing about relation we are accessing. Relation is a fancy name for table. Some people told me that if I studied CS at my university with greater care, I would know that tables are relations. Right? Cartesian products, blah, blah, blah. It's all about algebra. I didn't know it when I was studied. Wish I could start my studies now after, all this. But hey, oh well. No one would have believed that I could deliver anything. Anyway, so this is because, ladies and gentlemen, we provided this base relation, and it's bare relation. It offers nothing, just to announce, that, I'm here. But okay, that's not enough. Let's click this base relation. Let's see description. It represents a collection of tuples, blah, blah, blah. Oh, boring. Okay, let's skip it. So, blah, blah, blah. Then you see other interfaces. You see other interfaces like table scan, prune scan, and that rings a bell. Right? Doesn't it? It says that there is something like table, like scanning, like pruning, filter pruning. You may have heard it before. And this is exactly the purpose of these interfaces. Announcing to the outside world that we are supporting, for example, full scan, or scanning with filter pruning, and other goodies that Spark leverages to make your queries faster and to avoid loading all the data from external data source, rather than only what we need. So whenever your query uses filter or where in SQL, it may or may not be available as an extra information to your data source. So let's use something I like very much, pruned filtered scan, okay? It's to say, I'm supporting filtering at data source level, rather than downloading entire data set onto executors JVMs. We will do the filtering at the base, at the bare metal. So before sending petabytes of data, we filter them out and send only subset of this data, because that's exactly what our query needs. So pruned filter scan. We can read base relation that eliminate unneeded columns and filter using selected predicates before producing. It's about columns, column pruning. And there is also prune scan. It's about eliminate columns. I think it's better than this. OK, so pruned filter. Good. So let me switch to this. And ladies and gentlemen, we are prototyping, so we extend this. And then we need to implement one extra method. And we are done. Really? Let's see. You see, just 40 minutes and we've got something, another exception, but still, look at this. It's not something we haven't seen already. It's just implementation missing. Well, because we didn't know what exactly we need to provide to the infrastructure of Spark SQL, but now we are guided by these exceptions. We love exceptions, me including. So I click this, and look at this. It builds scan. Well, it builds scan. Well, I expected something else, but anyway. So let me provide this RDD. Have you ever coded your own RDD? It's just another, there is at least one person in this room. Yeah, 2. So, 3, okay, 4. Yeah, 4, okay, 5. Yeah, 5, 6, okay, 7. Oh, yeah. Okay, so everybody in this room had so much time, and they extended Spark with their own custom RDDs. RDD is nothing else like a metadata about this distributed computation that Spark will execute as tasks once this planner, RDD planner, decides to create that number of tasks. So all the partitions will become tasks. These tasks will be executed for all the stages. Stages are created for all the RDDs that are in RDD lineage, blah, blah, blah. And OK, another 40 minutes passed. So we know that we need to implement RDD. We've got no idea what it takes. So let's do this trick and enter. We're done. So we implemented this, and we need to provide, the constructor needs Spark context and dependencies, because we can create chain of RDDs. Every operator in RDD API creates brand new RDD. So all these RDDs create this computation that eventually will be executed in this distributed environment of Spark platform. So first, SQL context, Spark context is available through this Spark context. And second, we've got no idea about all the dependencies we may or may not need, so we just nil it, which means no parent dependencies. It's only us, and that's it. OK, let's see what's going to happen. Again, we are only providing minimum for the implementation that Spark SQL requires. OK, oof. Yet another exception. This time, it's the last one, I promise. Oh, no, I didn't say it. So SQL context, OK. It's a silly mistake, because we get this SQL context here. So again, the trick with this schema, I thought we should have make the change before, but we didn't. OK, let's run it again. So again, I just copied what was given to the place that was requested for this information, knowing nothing about what I'm doing. I'm just trying to meet the expectations of Spark SQL. Success! You see? It took us 40 minutes plus break, some conversation. We had long conversation. So meetings, 2 meetings. We had 2 meetings perhaps along the way. We delivered our very first data source. It does nothing at all other than to meet the requirements of Spark SQL. But hey, we can play around and now have time to explore how to access this external data source better. When I've been working, I am still doing it. When I've been working with Splice Machine and Cloud Spanner, I knew nothing about these external systems. And I told these companies and, Google Splice Machine, I don't want to, spend time exploring, nitty-gritties of this product and that product. I don't want to be an expert in this. Just tell me how to access external system. And they said, okay, do this. And I just took the code and made it part of Spark's SQL, Spark's code, the code base I'm writing, and it was fine. And I said, hey, from Spark perspective, it's okay. Is it okay from Splice Machines or Cloud Spanner's perspective? And they said, yeah, we tested it, it's okay. And I said, okay, it's okay, fine. So we closed the deal. So that's exactly what I would expect from people extending Spark SQL. You don't have to be an expert in this external data system. You should expect that you will have subject matter experts available, readily available, so you together can work and provide data sources data from these external data systems to Spark, to this unified data platform. Okay, so we've got this weird-looking, name. This is just a Java way to announce the name of the class. So, and you know that this is just as simple as this. This is something you need to know about Java and Scala, not necessarily about Spark. Spark uses whatever is provided by this base relation, so you can just overwrite this toString, and provide the name of this, and this is the place. Okay, let's see. You see? So this is the place. So now, ladies and gentlemen, you've got this empty schema, because we haven't changed this schema. Let's change this schema to something more sophisticated. So struct field, and it requires ID, type, long type. Okay, it should be fine. And it's a list, so nil, and it should be fine, right? No, okay, like this. Oh, yeah. Okay, so we created schema. So we users, data scientists, data engineers, we decided that our data looks like this. It's a struct, and it's an ID. It's only ID. So we only expect numbers out of this external data system. So let's run it. And let's see what we will see in this, query plan. You see? Now, we are reading schema using this struct big int, because this is what we've been given and what we returned to our to Spark SQL infrastructure. We haven't pushed any filters, and we've got this nice name. Let's change it to something more sophisticated. So now I would create something like object. Blah, blah, no, there is no object. I know that there is a way to create, no. There is a way to create object to your class in IntelliJ IDEA, but hey, we are not here, so val, name, or name, and I'll use this, or short name, even short name, or even alias if you want to. And now I'm gonna do this, change, and short name, and I'm gonna use this here and here. Good. Let's see if we didn't break anything. It should be fine. Yeah, it's okay, okay? So we changed the name, scan hue, ID 0, pushed filters. Okay, so are there any questions? No. Fine. Okay, so, but what we did here, we only loaded data frame, okay? So, hues. Okay, so we loaded, by the way, we know that they are IDs. IDs, okay? So we created these IDs. So let's show it. Let's show it. Let's see what's inside, okay? That's the next step. So first of all, first step is to make sure that this infrastructure, Spark SQL, accepts our brand new data source. So let's run it and see what's going to happen. The only change was to introduce this local value, IDs, and we showed them. It won't work, and you know why? Well, you can expect that, with this very basic implementation, it won't work because, well, our RDD, you see, get partition, is not available. So let's click this here, and now it's getting crazier and crazier. Our custom RDD, get more sophisticated. So what I would do, and that's the moment where I explain why I call this hue relation provider. This class is because of this create relation that provides this base relation, okay? So it's just a convenient name to announce that this is the provider I have registered in this meta-inf services file. Second, I'm gonna create this base relation, brand new base relation. So now I'm going to create a class. So I need to refactor this in a slightly different. I need to refactor it so it's more maintainable. One day when I say it works, people take it and it's going to be production ready code, and then I'll regret all the decisions I made in this code. So all the crappy codes I wrote. So here I'm gonna, before announcing that I'm ready, I'll do this. So this is base relation. So hue relation or base relation, it's a class. It extends base relation, and all the niceties that are here, I'm gonna move to here. And okay, now, ladies and gentlemen, you know that we need something from outside world, right? So we need to new it. So rather than this, we do this. Okay, it's okay from this perspective. It's okay. Let's format it. Okay, and let's format it with optimize import. Good. So we are fine here, but we haven't finished here. We need this SQL context. The easiest is to just request it. So, SQL context, and second is this schema. Oops, I do this, and oops, and this. Underscore schema, it's struct. Usually I'm more, I'm more clever than what you can see, but okay. So, now, ladies and gentlemen, we are fine there, but we are not here. So, just SQL context and schema. Done. Let's see if it works. By if it works, I mean whether we have this exception we had before or not. Yeah, it's okay, because it was about this implementation missing, and it was about get partitions. So let's think about this, but now we see huge relation. You see? Huge, not huge, hue. Sorry for this. So let's refactor again. So it was huge refactor to introduce hue relation. Okay, let's run it again. The last time we see this exception. Okay, you see, now it's hue relation. Very good. So now, ladies and gentlemen, this is what we need to provide, okay? What's the easiest to meet the requirements of this method? What's that? Exactly. Or, even better, so you know what I'm doing, array empty. Let's see if it changes anything. It should. Definitely it should. Wow! You see, it does work. So, yeah. Okay, ladies and gentlemen. So, now you see that whatever was defined by your code, your end user, is now printed out to ID and name. And this is string type. Okay. What? String type is... Avro. Yeah, you need to be extra careful. Blah, 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 blah. Okay. So now, ladies and gentlemen, let's run it again, and we'll see that sometimes okay, I'm not gonna change too much. Now, ladies and gentlemen, you will see ID and name. Okay, so the question is how to make data available in this data frame. And again, it's just data frame. So yes, we did load data because we did show, and show is nothing else but, well, blah, 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 system, go to sleep, no system, I wanted to sleep, but it's not. Oh, thank you. Thank you. Yeah, okay, thank you. Time unit. And days, oh yeah. And 2 millis. And 1. Okay, so 1 day. Yeah, and let's run it. What I'm gonna show you here is this. Localhost 4040. And now, ladies and gentlemen, oh, it's not here? I expected to see it here unless I've got, because it runs on 4041. Let me check. What's the port? Where's this 4041? Where is this? Blah, blah, blah. Oh, 4041, yes. Ha! Yeah, beauty of working with Spark. Yes, so now, ladies and gentlemen, you see, this is the show that I've been doing so far. So show at hue data source test. So when you click this, you will see that this scan hue with all the beauties that I defined are available in Web UI now. Okay? So this is weird, this name, so let's change it. But that just hue demo. Okay, let's run it again. And the reason we are changing this is to make our end users' life much, much more convenient. Oh, you see, it changed. Here, nothing, not much, okay? So here, it's a whole stage code gen, which is very sophisticated optimization. Okay, let's have a look at the details. So you've got all the information that you provided the very first time. Pushed filters. Let's think about these push filters, okay? Data. We haven't talked about data. Data is empty. So let's make it, let's provide something, okay? So what do you think? Who is in charge of providing data? RDD. The RDD we create from this relation. This relation describes the outside world for Spark SQL. Now it's time for the low-level infrastructure, RDD API. Yes, eventually we need to deal with this RDD. In DataSource API V2, you will see this less and less, but we are with DataSource API V1, so, well, you have to deal with it too. So hue relation, remember this, we created this RDD, right? So let's change this array partition to be just one partition, okay? So let's create this custom RDD. So hue RDD, yes, that's right. So Scala class, hue RDD, it's gonna be a class. And now I'm gonna take this code, not really this. Okay, let me extends RDD. And now it's gonna be, now you will be dealing with this weird types. And T, and here, this is just the beauty of what? Of Scala, and this, and now you extend this, class accepts Spark context, or even Spark context, Spark context directly. Very good. So now you can just pass it here. Okay, 1, 2, 1. And now, ladies and gentlemen, no uses, right? We need to take this code. And hop. And remove, optimize. We're done. Right? And here, we need to change this to use new hue RDD. Very good, and then what do we need to pass? Spark context, which is SQL context, Spark context. Very good, fine, good. And let's go back to RDD. RDD requires this extra information. RDD, blah, blah, blah. So I'm importing all this. So compute, you see, compute needs to return, compute, what's the problem? Iterator, override, doesn't conform. Oh man, I don't know what happens. What I do in this context is implement methods. Now I'm fine. Okay, and let's change this to return array of partition, and let's see what this partition interface requires. Okay, so let's see. So partition, it needs this. Okay, so array of new partition and implement methods index just 0. So we created just one simple partition. Usually, you would introduce something like hue class, hue partition, extends partition or implements, right? Yeah. And implement, and extends is fine. And here you do this. And I'm lazy. No, I'm not for now, because I'm introducing too much. Hue partition. Okay, very good. So, ladies and gentlemen, let's see if I get rid of this empty. Oh, no class tag, blah blah blah, Spark context. What is this? What is this? Who's gonna help me? Was that? You mean this? Oh yeah, why not? And now we support rows only. Am I fine? Yes. We've got no time to think about a better way to deal with this for now. Oh man, no, we have to think about it. So what I usually do, and that is just to show you how to recover from the situation, is to see what's available in Spark SQL already, right? So I'm usually looking at data sources that were available. For example, Kafka. Kafka is pretty awesome. So I go to RDD. You see, this tag class is needed. I've got no idea what is this for. I usually do, but this time no. And I see all the nice. I see continuous shuffle, continuous data source, RDD, empty, and then let's see if there is something, oh, JDBC RDD. It's also cool. So let's see how they, internal, but why didn't extend? The obvious is to just remove it. Yes. 5 minutes, yeah, 5 minutes. So we need to get rid of this. QRDD. And this should be fine, right? And that's gonna be it. Oops. Hopefully. No! Type parameter. Does not take parameters. Yes, right. Oof. This is just compilation error. The previous one was also compilation error, but hopefully, oh yeah, we pass it. So now, ladies and gentlemen, okay, now we get another error because we created this one partition and compute needs to return iterator of rows. Row and ID 1 and Spark AI Summit. Okay, let's see. Yeah, should be fine. Please. No, let's see what we see here. You know what's this? Yeah, exactly. That's just a minor issue, as they say. That's it. Yeah, and 3 minutes left for questions. Woo! Yeah, yes. Okay, guys. So, ladies and gentlemen, we haven't discussed writing part of this custom data source development, which is going to be part of next year's Spark Summit in Amsterdam. In Amsterdam, hopefully too, or in Warsaw perhaps. So, but the process is exactly the same. As you can see, I haven't looked into the internals of book that's readily available on the internet, whether it's written by me or by someone else. We only rely on what's available in the Spark SQL source code, and that's what I encourage you to look at, because although it's not, the very sophisticated code to learn Scala from, but still it gives you just enough to get going with this custom data source development. So, yeah, that's pretty much it. Wish I could spend more time on it, but time ran out. So, yes.
Give it a big hand to the man who is doing this under spotlight. He just told me that he'll be doing the live doll session at the party tonight. So if you didn't get in out of it, come and join him tonight. We only got about a minute and a half, so I'll take maybe 1 or 2 questions because we have another speaker coming up. So if you have any questions, please come up to the mic. We had 2 mics on either side of the podium. I think we only have about a minute and a half to take 1 or 2 questions. So go ahead, sir.
So quick question about actual placement of partitions on individual executors. Can you adjust that by implementing your own data source?
Yes, exactly. And this is a very good question. The question was about how to influence partition placement or where computations happen, correct?
Yes.
It's part of RDD. This is this description. So since we haven't implemented this method, get preferred location, we haven't specified where to execute it. So to answer your question, since we are developers and you are interested in it, you need to implement or override this method called get preferred locations. Okay. And if you get preferred locations, you specify the executors you've got available for your computations.
Okay. Thank you. How about you?
Thank you. So how do you implement predicate pushdown?
How do you announce what?
Predicate pushdown.
How do you implement predicate pushdown?
Predicate pushdown. It's another very fine question. I'm ready to answer. So it's part of Spark SQL, correct? So this is this predicate filtered is here. So look at this. We haven't specified override method and unhandled filters. So by unhandled filters, you specify what filters you don't support. Okay? So by implementing, by overriding this method, so in other words, you do support filter push down, but you can be more explicit about it. Okay? There is another interface that you may implement because there are two push downs. One is, it's filter push down, so it's about number of rows. So I think it's this. Yeah. And you need to be extra careful because you are dealing with two filters. One is from data source, another is from predicates. So there are some confusions coming, so ping me offline and I'll help you.
I'm sorry, we're out of time. He's going to be on Stack Overflow. He's there 24/7. So
exactly.
you might want to post questions to it. Give a big hand again to Jacek. And thanks a lot for coming, and we'll hope to see you tonight at the party too. And he'll be there, by the way.
Thank you.
Thank you.